Perfect.
There we go.
So I think let's get going, and we'll have lots of people coming in, I'm sure. Today's a really interesting session. I'm going to introduce Joseph, and we'll get cracking. Joseph Guyan, he's the digital product manager for Answer Data. He's been involved with case hole analysis for coming up to 15 years. I know he doesn't look it, but he's actually been in the oil industry for more than 20 years. Answer Data is an independent specialist in case hole analysis, specializing in casing integrity, production logging, cement analysis. I know a lot of you know that anyway in other areas. Today, Joseph's going to talk about their new AI-enhanced software for the analysis of multi-finger caliper data. So, Joseph, over to you.
Thanks, Fraser. Thanks very much. Sometimes it definitely feels like I've been doing this for 20 years, and I know that Zoom's probably touching me up. There's a little feature in Zoom to touch your video up, so it's not all as it seems. So yes, multi-finger caliper processing. So that's been a big part of our day-to-day work at ANSA. And over the years, we've been seeing that many aspects of the service are ready for improvement. So coupling that with the advancements in processing techniques, our CTO especially, he's Marilio Adario. He's on the call at the moment. He's led the development of Clarity, which is our new platform for caliper analysis, and he's available to answer questions at the end of the session as well. So I'll be demonstrating Clarity shortly, but first I'll be starting with a few slides just to introduce key concepts before moving on to that demonstration. A lot of the elements in the session they're all worth a couple of hours of discussion at least. And so what I'm hoping to do today is really serve this up as a taster and prompt some questions, prompt some thoughts. We can talk about those at the end of the session, and that can help us lead our thoughts for what we want to talk about in future sessions. So we'll start with broad strokes. In the oil field, when it comes to making decisions based on logging data, you're quite often forced to wait. So you've got the service company on your well acquiring data. You wait for that data to be retrieved, transmitted to an expert. You're waiting for that expert to report back to you. Of course, in this setting where time means money, and also the work needs to be completed at literally any time, the last thing you want to be doing is waiting. That's really where ANSA has come in with our developed software Clarity. We put the ability to get those answers from that job into the hands of more people who are closer to the action, all without compromising any quality. So that's Clarity. It's an AI-enhanced software tool for the processing and analysis of multi-finger caliper data. Clarity is newly developed from the ground up. We're taking advantage of modern processing techniques and computer power. And also, we're taking advantage of our team. We've got a lot of people here who've been doing this job for a long time, using other pieces of software. So we know what we want to fix. Looking at the general topic of artificial intelligence and machine learning, it's a huge topic at the moment, and you've no doubt heard about it already. If we look at it in the world, we can see that medical scans are being assessed quicker and more accurately, or helping experts to assess those scans. We see the AI analyzing market trends and performing trades. We see AI generating content, articles, blog posts, and even computer code. So just like all these well-known applications, we're using AI and ML techniques to help you become an expert with logging data. We're trying to speed up time-consuming experts of checking data, time-consuming elements, of checking data, processing it, and then presenting it. You need to process the data and then give out that report at the end of the day. So this is where we're helping you. Just like where your phone might be telling you where to eat that night based on what it knows, Clarity will be telling you and your crew offshore what steps you should be taking next. So we're narrowing it down a little bit now with multi-finger caliper processing in particular. As I talk to various elements of Clarity, wherever we're solving problems for you quicker than before or more accurately or reducing complexity, this is basically where our expert system comes in. So an expert system allows for consistency of approach, cost reductions through reducing human involvement, all the while increasing accessibility. So we call this expert system PRISM. So this exists within the software Clarity. Wherever we're using these new techniques to make the job easier, we'll be using what we call a PRISM module. And I'll just talk to a couple of those before the demonstration. So data quality. Many of you in the audience will know data quality checking is an absolutely essential process. So you want quality in to get quality out. You want to identify any issues that are present in your data set that might hinder your interpretation. So you can use the Mark 1 eyeball to scroll through your data set, or you can use PRISM quality check. So we're scanning the data for you in seconds. It is literally seconds. For any patterns consistent with any of the quality issues that could affect your data set. We'll see this action in our demonstration, but this is what it's going to look like. So it's actually going to scan your caliper data set and report on some of these tests. So perhaps looking for clogged or malfunctioning arms, tool stick and slip, which can affect your data set and affect your interpretation. And on the screen there, we've got a report of some data spikes. So a spike is very easy to identify automatically. So and we'll see that getting treated in the demonstration. So this report really just highlights the issues, saves time scanning. We can also offer editing tools at this point as well. Next, I'll touch on centralisation. This is one of those topics that is easily worth a number of hours. You can talk about this forever. If you want to break it down very quickly, it's a process that you absolutely need to do. You need to deliver some of the values that you can talk about in the report. So it's a great place for PRISM to actually interact and help you, because there's a number of parameters and options that are available for users to choose in different pieces of software. And that takes expertise. So this is definitely one of those places where you want to click on PRISM centralisation to give you the correct answers. In the real world, on the left-hand side in the picture there, you can see the raw data. So your tool string in the well is sitting closer to one side of your tubing than the other, just due to natural effects of gravity and the weight of the tool string. So you need to essentially correct for that in the software and give you an image closer to what's on the right on the screen there. I'll talk about it in a bit more detail as we get into the demonstration. But on the screen here, you can see a visual representation of the choices that Clarity and PRISM is making for you. So on the left is your recorded values with a number of high radius values and a number of low values. So centralizing this data set should require a varying number of parameters to be chosen all the way through. In reality, what happens is a compromise situation where somebody the analyst will be forced to choose just one to cover this little interval here. So we have only 2 feet of data on the screen. You're probably going to choose, a person would probably only choose one method here, whereas Clarity can actually, if required, can make a choice at every single depth step. So in this case, 2 feet, 200 data points, 200 depth steps. A human is never going to be able to make 200 choices here just to cover 2 feet of data. And the average survey could be 8, 10, 12,000 feet long. So this kind of processing technique and power is new and available to users of Clarity. We're going to get stuck into it's actually a video of Clarity, which I will talk to. If you ever get me for a beer, I will tell you why I'm talking to a video. Nothing's been doctored. We're playing at real speed, so I'm not trying to pull the wool over your eyes. But the demonstration is going to concentrate on PRISM workflow. So this is a very specific aspect of Clarity. It's designed to take the user through from the import of data all the way through to the report. And we'll do this live, essentially live. This is a great introduction to many of the processing elements, and some of the terms and phrases might confuse you if you're not familiar, but please feel free to get in touch and we can talk to those next time. So if you just give me 2 seconds, I'm going to switch my sharing screen. Here we go. So I'll just talk to this screen a little bit at the moment. So we've got, this is clarity for you. This is how it looks. Now, something that we're really proud of is the layout and the user experience. And we've worked really hard to make this very comfortable for the full spectrum of users to get started with. So it's a really good place to start. At the top, the various controls can have the, let me just draw a nice little square for you. There we go. Along the ribbon there, at the top, that's where you find all the manual controls. So we're going to talk about PRISM workflow, which is the assisted stepping through of the data. But all the elements of the processing tool are at the top here. So you can take control if you wish at any point and start to see the full control there. In the center of the screen, let me draw another square. Here we go. So we've got simple viewing controls there. Clarity is really good at loading all the data in, taking advantage of modern PCs and the vast amounts of memory and storage that you have. And it loads the data in really, so you can then browse the data really quickly. So viewing the whole range, it literally takes the click of a mouse. Let me just clear my screen. There we go. And the display is fully customizable as well. So you can control the color map behind the arms here. You can control all of the, let me just get my pen. Here we go. So in this section here, that's where you can control the color map. But PRISM actually is going to help you there as well. So before I set up this project, so I've imported the data already, and I've told Clarity what tubing size we're working with for our survey. So in this case, it's one tubing size. And as we start workflow, it actually draws this color map based on your pipe dimensions, and it helps you there straight away. And you can have multiple color maps for multiple pipe sizes. It's all on the same screen at once. Everything on this side of the screen, you can control the display of as well. And there's no limits to the number of tracks. It's how wide is your screen. So you can display other data there on the sides too. So we've got also during import, you've specified a couple of other project properties, and we'll see those come into play at the end when we talk about the report. A lot of the sort of more tiresome aspects of writing a report, well names, which tool you used, some other aspects, the well name, which company you're working for, all that can go in at the beginning, and we'll see how that comes into the report at the end. Let me just start the video off and see where it takes us. So along the left there, where the cursor is at the moment, I'll just draw another squiggle. There we go, over here. So we're working down that side of the screen, all the way through the different processes that will take you through to the report. The first step is centralisation. So I'm going to leave it running here. This survey is about 4,000 feet long, so it's a little on the short side. And you can see in the background there, let me just pause it and draw a little circle. There we go. So in the background there, that's the part that PRISM's taking care for you. It's which parameters to choose while you centralize the data. So the outlier count, the geometric function, the method. It's choosing, like I said, the best solution at every single depth point. So differing well conditions is why you want to do this. If you have deposition and high radius values from damage or corrosion, you really want to vary the method all the way through the data set rather than being forced to choose one or possibly two or three. And it's making those choices all for you. There's our centered data set. Simple, yeah, there we go. I've just clicked on full range there to show the whole thing. Simple viewing controls, just like for a Microsoft document, it's all easy stuff. Control and scroll to move through it. And mouse wheel to move up and down. Pause it there for a second. Here we go. This is quality check in action. So we'll see how long it takes. There we go. That was for 4,500 feet, I believe, or 4,000. And it's detected some spikes. So we'll see what can I know about my spikes here? I'll click on this zone here, and it's found me a couple of spikes. So I'll click on the eyeball. I'll show it on the screen. Spike is really quite easy to detect. It's definitely something you want to remove. We see spikes as from telemetry errors, perhaps tool errors, or interference at surface from your cabling. It's all sorts of stuff. and you don't want these sat in your data set appearing to be holes. So let's get rid of these real nice and quick. And all we've got to do over here is just select them for editing. There we go, and auto edit. The other tests there, I'll just pause it. And the other tests that we've got at the moment, stick and slip. And if you're not familiar with that, irregular tool motion, it's very difficult to correct for, if not impossible. And that can impede on your analysis. So unfortunately, it's basically impossible to fix as well. So you need to know it's there. And you need to know which zones you want to look at. We're looking at, this isn't the end of the story as well. I'll refer to this again as we go. But we are continuing to work on what we check for. So deformation is definitely going to go in here. Deformation is also a feature of the tubing that you're not going to correct for, as such you don't want to edit that out. But during centralisation of the data, you can mask the presence of deformed tubing. So during quality control, you really want to find those zones, and so you can report on them later. And that's coming too. Now on the left there, we're just hovering over next. Again, this is PRISM workflow. Rather, if you look at the top of the screen when you've got all the options are available for you, an expert would definitely be able to work through these and pick it up really quickly. But a novice user or someone who just wants to get through this a bit quicker, they definitely want to be using PRISM workflow. It's where to be. You can just move your way down on the left side here. So here we go with PRISM depth correction. Now, you saw how long it took again. It took a couple of seconds there. Earlier on in the process, when I set the project up, I entered some values for three completion items, so a safety valve, an SPM, and a nipple. So depth correction, again, essential process for processing caliper data. You want to match your data to a known reference. And typically in this world, we use well schematics, and we use items on those schematics to correct the data too. What we're doing with PRISM depth correction is we're scanning the data set for those items and finding them automatically, and then creating what we've called depth pairs. So you can see expected and observed depths. And on this little window on the right, you zoom in, and that's where PRISM has automatically found the top of that SSV for you, the safety valve. We're going to look at towards the bottom. And I'm going to make a change here. It's a simple matter of clicking and dragging that red line. So these depth correction points I've created now, 3 of them, just like that. I haven't had to scroll through the data. I haven't had to type any numbers in, type any new numbers in for the observed depths. I've created what we call a shift table. So we're going to shift the data to these 3 points using those values. And what I can do is save that depth correction table for later use or reporting, because some customers like to see what depth corrections you made, perhaps for next operation. If you need to find a particular joint or item for your next intervention. And then we hit apply, and that's our depth correction done. So you can also add in manual items there, so a manual rows. So perhaps you wanted to put in another zone there's a zone of interest, when you're away to set a plug somewhere, and you know the 5 joints that you're going to set it in, and you have a tally. You want to be really bang on depth for those, so you can add it manually as well. Right, so I'll pause it briefly here for what we've called recalibration. This is another big topic. You can talk a lot about recalibration. So the quick version would be, so your tool is calibrated at the well sites by the engineers before they run it. So that's done. That's not what we're talking about here. What we're offering here is a software tool to correct for various things. So temperature related drift is one of the big ones that you might want to have, that you might be forced to correct for. So tools are normally, the caliper tool is normally corrected for temperature. But there are instances where where you see temperature related drift and you have to correct for it. And that's a very manual process. It takes the user a fair amount of time and experience. So the first thing we do in PRISM workflow is ask, right, if you want to correct for this, can we have the nominal IDs of the colors? And we use that to correct the survey for any temperature related drift. Big topic, and that I was just an intro for you. But what we're actually going to do with this data set is we're not going to do the temperature related drift correction. Yep, we don't care about color nominal IDs for the moment. We're going to click on I don't know. There we go. Pause it here. So we're going to do what we call a modal joint ID recalibration. So no matter how well your tool is calibrated, you can make a small soft touch recalibration using the data. You're not forcing it to any new values. You're just doing a soft touch recalibration to tidy up for any minor drift between your arms. This is, I would say, present in the vast majority of surveys, and we can easily correct for it with PRISM recalibration. In the background there, I'll just get my little pencil. Here we go. You can see a top depth and a bottom depth. What the experienced user has to do is spend time looking at the data set, deciding which zones to use to correct the rest of the data set, and where to create shift values. And that can take time and experience. So again, another great place so we can save you time. So we've created this shift table for you, saving you a whole bunch of time. That's that table in the background, and it's just going to go away and apply those changes. And when it comes to using Clarity for yourselves, each time we run a different process, we're creating a new data set within the project. So if you want to, you can. It's always a good idea to have a look at the recalibrated data set, which is this one on our screen now, and compare it with your first data set on the way in. Reorientation, that's a simple step to apply. As we set up the project, we told Clarity which curve you need for the reorientation process, and another piece of information, which is which arm was up during the calibration process for this sensor. So you need to know that from your acquisition company. The defaults are typically presented for you on the screen there. So counterclockwise is the direction. Arm one is usually the right one. So why do we reorient data? It's a great tool for visual understanding of the data. So your MFC tool string will rotate as you log up during your survey. And depending on your experience level, that rotation can kind of confuse you a little bit. But so you can actually remove that effect in the software. So perhaps if you want to know, does my SPM, is the mandrel facing the high side or the low side? I can't tell because my data it's kind of twisted around. So I reorient my data, and that means the high side indicator will tell you exactly where it is. It's an optional process. Many people don't do it. So here we go. Now, you blink and you miss it there, because what we've done here during joint identification, we found every single color that we need, because what we want to do is break the survey down into the joints, individual joints of tubing and casing. And we've got an awful lot of data here. And if we ever want to talk about it in the report, we need to extract one value per joint. So the maximum penetration, the minimum ID, so we can effectively interpret the data visually. So we can look at some charts and tables. And to do that, we need to find all the colors. And that, like I said, it's already done. All these red lines, this is the whole survey. These are showing you where all the colors are. On the right-hand side there, I'll get the pencil. There we go. Got a few tools that control the display of this table. That was a really messy circle. There we go. That's not even there. Anyway, sorry. Much better circle. Thank you very much. Over there, we've got some controls to alter the display of this table here. So this table is going to help you when it comes to fine-tuning the color detection. So I'll just press play again. Anything that's highlighted red, you might want to take a look at. You can double-click on this table to have a look at some of these completion items, or you can use the normal controls to zoom in. So what we're working on with Clarity is using these profiles to automatically identify completion items. So that's a work in progress. At the moment, we've just called this completion, but I know that there's an item that we've successfully identified in this survey. We'll see that in a second. So a shift click gets you a new joint. There we go. I'm going to look back at the table, or I can just scroll down the data set. All these joints all found. Now, normally you'd be, I'll pause it for a second. Normally you'd have to control the detection of these joints. So you would have to perhaps pick an amplitude threshold or some kind of parameter that helps the software find these joints. Not so here, you just press one button and it's found them. You decide, typically I'm going to put in some pup joints here around this completion item. Completion items as well, I should say everything with the word joint in the annotation column on the right-hand side. What shape shall I use now? I'm going to try a rectangle. There we go. Just over there. So yeah, everything with a joint is going to be taken forward into the reporting and all those charts and tables that we'll see shortly. Anything with any other annotation will be set aside because we only analyze everything we know the dimensions of, which is essentially the tubing or the casing or the liner. There's a nipple there. Blink and you'll miss it. Let's see. Just go back. There we go. Just on the screen there. So we found this as a nipple, and that's exactly what it is in this particular well. We're going to add another completion item here, a bit of a peculiar one. And I'm just double clicking on the right-hand side there in that annotation column. There we go. Thanks, Mario. SGM. There we go. So depending on the length of your survey, you can be a long time here as well. It can take a long time to create this table, which is utterly essential for processing your data. You can imagine 12,000 feet, 3 times this. I should mention on joint identification as well. That's where machine learning is taking part. That's one of the processes we forgot. It's actually quite funny because I realized that a lot of the really clever stuff in Clarity is hidden away. It's so easy to use, you kind of forget what's going on in the background. So there you go. That's the identification of the color profile, regardless of whether it's long, short, whether it's narrower than the tubing or higher than or greater than the tubing. All that's taken care of using machine learning techniques. So this is by this stage in the what we call compute statistics, we finish handling the data, and we're going to create a selection of new statistical values from the data to help reporting. So those are the maximum penetration values which describe corrosion and damage, minimum IDs, which describe restrictions, and we're also going to use PRISM damage classification. Now we're applying descriptive text to each joint now. So PRISM looks at each joint and then describes it in a certain way. And we'll see that during the reporting as well. So we can classify a joint as having corrosion, ring corrosion, line corrosion, scattered corrosion, deposits, etc. I'll show you the list in just a second. But we're applying these English language, this language model to each of these joints to better describe things for you. Again, when it comes to reporting, all the help you can have to get to your report quicker. It's drawing a new screen for us now, so a screen perhaps a bit more suited to create for images in a report, just with some extra shading rules, so it looks a bit nicer. There we go. Someone's better at drawing squares than I am, that's for sure. Right, I'm going to pause it for a second here. So this interface here is where we create the report. So we're building the report from a Word document. So rather than have some kind of plain layout PDF that is created in the report, we let you make a template. So this template, you'll see it in just a minute. We've created it with our own branding and our own logos, all that sort of stuff. And but what we can do is help you create yours. So these templates are linked to Clarity with merge items, so it can take various values, various text and images, and get them all into Word for you. And then you can take that Word document away and perhaps make some fine-tune changes to it at that point. And we'll see that as we go. So as we work through each of these tabs, you can start entering some information. Again, this is where what we think you want to see in your reports, but it would be great to see more people feeding back on this, what they would actually like to see. We've included some sections for some typical items like some survey objectives, perhaps some comments about the logging job itself. What we quite often see as people wanting to have a summary section. So just answer the burning question about your survey. Are there any holes? What is the minimum ID down to 2,000 feet? That sort of stuff. And then a space for some more in-depth results too. We've got a tab here to control the visualizations. Again, this is where we're starting from. Do you want to include some images in your report? Here are some suggestions. Do you want to see a full range overview? Typically, yes. Do you want? Quite often, people want to see their completion items. Are my safety valves in good condition? Are my SPMs clear of debris? Pause it for a second here. This is where the PRISM damage classification comes in. So perhaps you've got a nice clean well, and all you want to know about are the higher penetrations. Perhaps it's the opposite. Perhaps you want to know how much scale and deposits are in my well, and do I have to do a cleanup? So you can choose to show just those categories there. And then typically what people like to see, where's the biggest hole? Can I have a picture of that, please? Or where's the biggest damage feature, corrosion feature? Or where's the lowest ID, and is that going to cause me a problem? One more tab, and we're nearly there. A selection of charts and tables that we feel are going to be of use to you when it comes to your reporting. Again, a start point, so we can tune these to what you actually want to see in your reports. If there's a particular layout you like to see, we've got things like the percentage damage aligned with borehole deviation. That's quite an interesting chart. And then we can classify things as well using different preferences. Really, how many joints have features of above 80%? Perhaps if that's your cutoff for a workover or a repair job. You can tune these. We'll help you do that. We're letting it run now just to see how long it actually takes to get a report. It's going to take those images for us in the background. The reporting is quite a bit, depending on your backgrounds, quite often the answer's already in your head, and you could phone someone up, you could send a quick email and describe the position now. If you wanted to skip the report, you want to keep the operation moving, you could easily do that. The delivery of a report, though, is typically required. The operator would like to see a record of what you've done. And some aspects of these, it's time consuming. You have to put in the field name, the well name, you have to put the customer name, all this sort of stuff. It all has to go in, and it all has to be right, or else you're gonna look silly. So you do all this at the beginning of the day in your project setup. You don't do it in a hurry when you're processing the job. You do it the day before when you can set up your project and you can get it all right. So here you can see the answer branding, the answer colors. So you can just imagine your own colors here. Aspects there include the word tabling. You can set all that up ahead of time so that the tables are automatically created. The headers are all automatically filled in. The table you've got there, it takes information from the project as well, so you don't have to waste time there. We'll scroll through now. You can then edit the report in Word, so you can carry on adding some findings yourself. A project for us is actually to help you here too, so we can actually look at the data. Using language models, we can take the Clarity process values and create some text around those, and then start you off, get you kick-started on the interpretation results with some actual text. Here's those plots. Just let that scroll. And just simple stuff. You don't want to be spending time pasting this in. I've been there, at 2 a.m, pasting in tables and fighting with Excel to get this into a presentable format. Same with these images. Yeah, you don't want to be cutting and pasting all night or all morning. Here's a table for you as well. Okey-dokey. It was a whistle-stop tour. I'm just going to stop sharing my screen. Here we go. So that was a whistle-stop tour of one data set. I mean, that was about 15, 20 minutes to process that one, and I recorded it as I did it. So it was a live one. So